Welcome everybody in AP Chemistry series. Today we're going to cover a questions about the calorimetry method. Okay, so let's read the question. The question says 4.25 gram sample of ammonium nitrate that dissolved in 60 gram of water. Okay, so we can look at this figure. We have amount of ammonium nitrate that dissolved in 60 gram of water, and as a result of doing this process, a change in temperature occur, and we can notice the drop in temperature occurs from 22 degrees Celsius into 16.9 degrees Celsius. The question is asking me to calculate the delta H in kilojoule per mole. Just keep in mind the kilojoule per mole for this solution. All right. So first of all, we have to say the first step is calculating the amount of heat, which is represented in terms of a Q. So Q equals mc delta T. The M represents the mass of solute and solvent. So we have solute, which is ammonium nitrate. It was 4.25. And we have the solvent, which is water. So you add the masses of solute and solvent, which actually represents the mass of solution. And then we multiply it by 4.18. But why 4.18? And what is the 4.18? 4.18 represents the heat capacity that is represented in C. But why did we choose this number? Because the question says, assume that the specific heat capacity of solution, which is C, is the same as the pure water. So the pure water has a value of C, which is 4.18. So I will use this value in here. Do not forget to include your units. We have grams for masses. We have joule per gram per degree Celsius for the heat capacity. And finally, we have delta T, which represents the T final minus T initial. And since we have an endothermic reaction, the T final is less than the T initial. So as you have a drop in temperature, this reaction is endothermic. Just keep this in your mind. And now we have the grams, okay? We have the heat capacity, we have the change in temperature, and actually it's represented in negative sign. And this is degrees Celsius. So at that point, you can see here, I can cancel out the units. I can cancel the grams here. I can cancel the degrees Celsius, and the only unit that left behind is joules. So we have 1369.7 joules. Okay, but you have to think more. The question is asking me to calculate the delta H, which means in kilojoule per mole. What I calculate actually is only in joules, so I have to change it to kilojoules first and then calculate the number of moles. So what should I do? In order to change your value from joule to kilojoule, you have to divide by 1000. Divide it by 1000, and then we get this number, which is in kilojoule. But now you have to say it's kilojoule per mole, then which means I have to calculate the number of moles now. The moles of what? The moles of solute. What is your solute? It's ammonium nitrate. So in order to calculate the moles, we have to apply the mass over the molar mass. The mass is 4.25, and the molar mass can be calculated from the periodic table. The 14 is for nitrogen. We have 4 hydrogens, and this is the molar mass for hydrogen for sure. It's again for nitrogen, and since we have 3 oxygens, this is for oxygen, and this is for the 3 numbers. Like you remember, like it's NH4 and O3, same number of moles right here. Now delta H is equal to minus Q over moles. So the negative Q, actually, it's already negative from here, and negative times negative is positive 1.3697. You just divide them over 0.0531, and if you divide them, these are in kilojoule, by the way, and here we have moles, 25.80 kilojoule per mole. So this is the way of how to calculate the enthalpy change of reaction. I just want to clarify that, like, why do we have positive delta H? Keep in mind that we have an endothermic reaction, and the endothermic reaction must be positive. So where does the positive sign come from? But in your mind, the law actually contains negative Q over moles. It's already in the law of the delta H. But we have negative Q because we have negative uh, delta T. So this number here must be negative, as it's negative, and then you multiply by negative again in here in Q. Then the Q becomes positive. So if you divide it over the number of moles, you will end up with a positive answer. So the delta H for endothermic reaction is always positive.